How are you all doing? You're back with Jono for another quick math lesson. Today we're going to solve simultaneous equations at the same time using our substitution skills, but this time we're going to have one linear equation and one non-linear equation. So this is really building on the foundations that we have from other simultaneous equations and from factorizing using completing the square. If you're not on top of either of these skills, please go have a look at my other videos that explain these in a little bit more detail. So we're still using substitution to find points of intersection. In our previous videos with two linear, we only have one point of intersection. But because we're dealing with a non-linear entity, or an x squared, we're going to have two answers. And this is because a parabola kind of looks like this, and our linear equation that cuts through it is going to go like this. So we're either going to have no solutions, one solution if it hits right there, or we'll have two solutions with this line that cuts it in two different places. So we've got to make sure that our final answer has two coordinates because that's the most likely outcome. So an example of these could be something like this. We've got y is equal to x squared minus 5 and y is equal to 2x plus 6. What I try and always do, it's nice in this equation, but sometimes your monic isn't by itself. So try and rearrange them if you need to in order for this to be a really quick substitution. So what I'm going to do here is I'm going to sub that first non-linear equation into the second linear equation. This just forces this to become, because y is x squared minus 5, it becomes x squared minus 5 is equal to 2x plus 6. So I can do this because it tells me what y is equal to in both equations, so they must be equal to one another. The thing that you want to do from here is make one side of this equation equal 0 and get all the other variables onto the other side. So this is going to become x squared minus 2x minus 11 is equal to 0. And that's just by minusing everything on this side over to the left-hand side. From here, we're going to have to complete the square. So we've got to half the middle term and square that and add and take it away immediately. So that becomes x squared minus 2x plus 1 minus 1 minus 11 is equal to 0. That first half of the equation is now a perfect square. So that becomes x minus 1 all squared minus 12 is equal to 0. To complete the square here, I've got a difference of two squares. So this becomes x minus 1 plus root 12 and x minus 1 minus root 12. And that's all equal to 0. So to find out what x is, I have x is equal to 1 plus or minus root 12. And I know that this is correct because it's a quadratic. I've got two answers, which fits in really nicely with my guess that there's going to be 2 points of intersection. So now I've got 1 plus or minus root 12. All I've got to do is sub this in twice. You might be able to use your calculator to do it a little bit faster, but I've got y is equal to 2x, which is 1 plus root 12 for this example, plus 6, which is equal to 2 plus 2 root 12 plus 6. If I collect the like terms, that becomes 8 plus 2 root 12, and that is my final answer for this one. You might have to simplify the third if your teacher's a bit of a stickler, but I'm happy to leave it like this. So the coordinate for this first point is that I've got x is 1 plus root 12, and the y coordinate is 8 plus 2 root 12. So that's my first answer. But now I've got to do this again using 1 minus root 12. So this becomes y is equal to 2, 1 minus root 12 plus 6. If I expand out, it becomes 2 minus 2 root 12 plus 6, which becomes 8 minus 2 root 12. Again, I've got to write my final coordinate. So this is 1 minus root 12 as my x coordinate and 8 minus 2 root 12. Because we had a parabola to start off, so even on both sides, that's why these look so similar as our final answers. If you leave them as decimals and whole numbers, it becomes a lot harder to see that, but this is really clear that this number and this number are very much related to this number and this number. Thanks so much, guys, and I'll see you later. Just a quick reminder, there are some free worksheets linked in the description below, as well as the notes from this video. If you've got a second, please like, comment, and subscribe to Quick Math for more content every day. Thanks so much. Have a good one.